Hi everyone. Today let's look at another problem. Here we are looking at problem 238, product of array except self. Given an integer array num, return an array answer such that answer I equal to the product of all the elements of nums except num I. Int I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O(n) time without using the division operation. Right. Okay. So let's go. So for example, if we have nums equal nums equals 1, 2, 3, 4, then the output answer is 24, 12, 8, and 6. 24, 12, 8, and 6. Now the second one we have nums equals -1, 1, 0, -3, and 3. So the answer for this is 0, 0, 9, then here we have -3, 0, 9, let's say 0, okay, 0, 0, 0, 9, 0, 0, right? Alright, let me read the problem description so see if I have any questions. So here we have integer array nums and array answer of I is all the product of all the product of all the elements of nums except the nums I. Product of any prefix or suffix of nums is granted to fit in 32-bit integer. We must write an algorithm that runs in O(n) time. O(n) time without division. So in here we will need to compute the product of all integer of all the element in the array except itself, and it must run in O(n) time without using division. So one question is it guaranteed that there will be a single element? How about the case where length of nums equals what if it is less than 2? So the constraint we are given here, 2 nums length 10 to the power of 5. Okay, so there will always be a valid answer in this case. And the nums will be from minus 30. Is there any chance? Any chance? Well, subset product. Sorry, I need to pause this. Alright, so now the next clarifying question is, any chance why the subset product? It doesn't, and it doesn't matter which order I did. Is it going to exceed 32-bit integer? And then here I'm going to assume that the answer is no, because the nums is from minus 30 to 30, right? So the maximum number that we can get from a number called 30, I'm gonna assume in the edge case where it is all 30. Edge case is all 30. 30, 30. Then there are 10 to the power of 5. So it means that this is 30 to the power 30 times 30, so 30 to 10. So this will be 30 times 30, and then there are 100,000 of them. So which means that the nums is going to be 30 to the power of 100,000. Wow, that's quite large. Okay, so it's guaranteed to fit. Answer I is guaranteed to fit in 32-bit integer. Right, so answer I will fit integer. Okay. Then there is a follow-up question. Can you solve the problem in O1 extra space complexity? The output array doesn't count the extra space as the output array does not count as extra space for space complexity analysis. Okay. Do you understand the problem now? Let me think about. Okay, so I can think of one way off the top of my head to solve this. Without using additional output, what we can do is we can create can use an idea of prefix. So let's say we are looking for answer I. Then we could have a prefix of I minus 1 times post of I plus 1. Then we can define the pre-I is equal the product of all nums up to I. So j from 1 to I, and then the post of I is the product of j from I to n. Nums j. Right? So if we have pre-computed the pre and post, then this will take like this will be an O(n) of complexity where each of answer I could we come up in O1 time. And to address the follow-up questions, which is to use O1 extra space complexity, we could use the input array as the postfix. Is it? Postfix. Then we're going to need the prefix. To do that, let me think about it for a moment. I think we can use one of the output and input as the prefix and postfix. So how can we do this? Okay, I think I got it. Right. So as we move along to calculate the answer of I, we could use a variable as the pre. So instead of using pre as the array, we can use pre as a could set the pre as a variable. So as we go along the elements of nums, we calculate the pre one second, let me think about it. So I'm thinking that if we could use pre as we go along the nums, so we have nums A, B, C, D, Z. Let's assume I have this, and then the pre, as I go through the answer of I could use. Now the first one would be the post of 2. Answer 2 is A. Now the pre, at this point I can set the pre equals A, and then this would be the pre times post of 3. Then the pre becomes A times B. Now the third one would be the pre times post of 4. This will be A times B times C. So we can use the input as the same. I think I got it. So we can. So as soon as we reach the answer of I, we don't need to post 2 anymore. As soon as we are computing the answer 2, we don't need the post index. The index 2 at post 2 anymore. and then which means that answer n, answer of I, this we're gonna need the pre times pos of I plus 1, meaning that we don't need the previous pos as we go along the nums, meaning that we could set the answer as pos. We could share the same array, share pos array as the answer. Right. Let me go through an example here to quickly demonstrate. So in the first example, we have 1, 2, 3, 4. Then let's calculate the pos, which is 4, 12, 24, 24. And then the answer will be the pos 24. Then the pre at this point would be 1. Then at this point is 12 times 1, which is 12. Then this would be updated to 2. Then this would be 4 times 2, which is 8. Then 6. Then we calculate the next answer, which is 12 times 6, 72. Sorry. This would be 6 instead. Right? That is correct. 24, 12, 8, and 6. The second one, which will be minus 1, 1, 0, minus 3, 3. Now the answer would be pos would be 3 minus 9, 0, 0, 0. The answer here would be 0. Now here the pre would be minus 1. Minus 1 times 0 is 0. Minus 1 times 1, which is minus 1. Minus 1 times 9. Minus 1 times minus 9, which is 9. Then this would be 0. Then 0. This would still be 0. And then at the end, we will have the 0 here. Okay. 0, 0, 9, 0, 0. That makes sense. Now for the edge case, say 0, 0, 0, 1, 1. I think this is simple enough. I'm gonna put minus 1 and 1. Right. So the pos here would be answer and the pre. This is 1, this is minus 1. So check it wrong. I think this would work. So let me work on the implementations. First of all, I'm gonna create an empty array, empty list as my answer, which is initialized to 0 with size nums. Then I'm going through all the num element in nums. Okay, so I need the pre to be initialized to 1, so that whatever number it multiplies with becomes that number. Okay, so the nums here, and then actually I need to iterate through the nums in the reverse order. So what I'm going to do is going to create a loop, and then I will go through from length of nums -1 to -1 -1. So the answer at I equals I think I better initialize the answer to 1 instead. It's easier. And then this would be the answer of I plus 1. Then I can do a modulo with length of nums, so that it goes back to the initial element. Then I multiply with the nums. So that will be nums of I. Okay, then this is correct. Then for the second step, second loop, I'm gonna fill in the answer again. But this time I'm gonna make use of the pre. So for num in num, answer of I. So what is the answer of I here? Okay, they got it. First of all, I'm gonna have to enumerate so that I can know the index y to update. Then the answer of I would be the pre times answer of I plus 1. Now the pre would need to be updated with the nums of I. I'm thinking that we don't actually need the pre-variable because we can embed it into our input. Yeah, that could be a possible solutions. Then I have gone through this path here, so let's make use of what we have right now. So I think this should work. Then we're gonna return the answer. Alright, Let me quickly walk through the code to make sure I haven't missed anything. Initially, I'm gonna create an empty array initialized to 1 of size the same as nums. Then I'm going through from the last element to the beginning. I'm going to fill in the post of I into the answer list. Then this would be the next element, and the next post times the current num. This is based on the idea that the post of I plus 1 equals post of I times nums of I plus 1. The post I plus 1 times the nums of I. Okay. And then doing so, I will have the post embedded into our answer list. The next step will be to compute the answers and also the pre. So I initialize the pre to 1. Then I'm going to multiply it with the post at I plus 1. Then I'm gonna update the pre with the num at I. And I do the same thing, and I'm gonna do the same thing until I reach the end of nums. Okay. Yeah, let me run quickly through our example here. So we have nums and then post the answers. So answers initially would be initialized to, so I'm going to start at the last element plus 1 mod by the length, which is the first one, which is 1. So 1 times 4 is 4. Now the next one would be 3 times 4, 12, 2 times 12, 24, 24 times 1, 24. Okay, work as expected. Then I'm gonna enumerate through the nums again, now this time from the beginning. Then I'm gonna update the answer. So initially the pre is 1, and multiply it times 24. Then update the pre to 2, the pre to 1. So I think I missed one thing. So 1, then 1 again, then 2, it becomes 2 here. 2 times 2 multiplied with 4, which is 8, and then 6. I'm gonna multiply with the answer plus 1. Okay, so I see a problem here, because the I plus 1, we don't have it, right? I think to be very safe, I'm gonna need to have an if here. I'm thinking about whether there is a better way to implement this function. Okay. Then we can just add an if here to check if I is the okay. So I think instead of doing that, what I can do is if I is less than I plus 1 is less than length of nums, else this will be the nums I. Then here I can do the same thing. If I plus 1 is less than length of nums, else it is nums I. And then here the same thing. If I plus 1 is less than length of nums, else we just take the pre, then return the answer. So I think this will work. And then when we reach the beginning, when we reach here, we will need the pre, the pause. Yeah. So the reason we cannot use the modulo is because it goes back to the beginning, right? And then when we fill in the nums, the answers at index 0 is there will be the post at index 1, so we cannot reuse the value there. So let me quickly input my solutions to the platform here to see if there is any issue that we got. So I'm gonna initialize answer to as a list of zeros. Then this will be the length of nums. Therefore, I in range length nums minus 1. Then the answer of I equals answer of I plus 1 times the nums at I. If I plus 1 is less than length of nums, else it will be just the nums of I. Or a cleaner solution, we just I can initialize the last one to be the nums of I. The last one is initialized to the last element. Yep, so that's how we can get the post, which is also the answer. The post, and then next the pre. Now we can go to for I range of nums, then the answer I is the pre times the answer at I plus 1. Now the pre can be updated into nums of I. Except that we are not gonna compute the last answer. Then we're gonna put in the last answer is at this point I have lost the pre. I'm thinking about whether there's a better way to implement this part. So how about I use my second idea there, where I update the input into, I'm assuming it is fine that very important. I'm gonna assume that I'm allowed to modify the input nums, right? Okay, so assume it is. Then I'm going to have a loop. Gonna need a loop. So what it does here is that I'm gonna skip the first one. Then I'm gonna set it to the last one. Now here I'm updating the nums. The nums of I equal the nums times, this would be equals, to the nums of I minus 1 times the current one. Okay, so finally when we put the answer into answers, set of 1, so we need to initialize the first one to be the post, which is the post of, let's see, answers of 0. Now this will be the post of post at I plus 1, which is 1, right? Then I'm gonna go through from 1 to the last element. I think not the last one, because the last one will just skip. So this will be the answer of I equals nums of I minus 1 times answer of I plus 1. Okay, then at the end, the last answer would be the nums of -2. Return answer. Let me run this thing. Okay, seems okay. Let us submit it. I'm a bit worried that, oh, we actually got it right this time. Yeah. I think this is an interesting problem, but as long as we are careful, you can make it. Thank you.